Alright, calculating and determining the empirical formula from the grams or percents. Well, we'll talk a little bit later on about this other thing called molecular formula, but for now we're going to look at something called an empirical formula. Now, your empirical formula is kind of a simplified version of a formula, and we'll look into more of that later. But let's go ahead and start up with how do we get the empirical formula. Well, step one says that you're going to convert the given grams to moles for each element. So if you look here at number one, it says a compound is found to contain 75 grams of carbon and 25 grams of hydrogen. What is the empirical formula? So first thing you need to do is go ahead and write down the elements that you have, okay? And we have here, we've got carbon and we've got hydrogen, okay? Now, sometimes they won't give you the grams. They'll give you what's on number 2, okay? And on number 2, you'll notice that they give you percentages instead, because it says what is the empirical formula of a compound that contains 70% iron and 30% oxygen. Okay, if you get percentages, just cross out the percentage there and write gram. And then you'll be good to go for step one, because in step one, what you need to do is you need to convert the given grams to moles. Step two says we're going to divide each mole calculated by the smallest number of moles found during step one. And then number 3 says the answers that we get from step 2 will basically give us the subscripts for our formula. So let's put that into action. First thing we need to do is we need to convert given grams to moles for each element. So how many grams of my carbon did I have? Well, they gave us 75.0 grams. And then for our hydrogen, they gave us 25.0 grams. Now, what we need to do is we need to convert these from grams to moles. If you remember right, the first thing we do is take that given and put it over 1. Put what we want to get rid of on the bottom, grams, and we want to convert to moles. Now, when we do that, if you remember right, we need to look at the periodic table to see how much carbon weighs. And carbon weighs 12.01 grams per 1 mole. It's always grams per 1 mole. And if we do that, we find that for our carbon, we have 6.24 moles. Now let's do the same for our hydrogen. We want to get rid of our grams, so we put it on bottom. We want to go to moles, so we put that on top. And for hydrogen, hydrogen weighs 1.01 grams per 1 mole. Again, that's found on the periodic table. So grams will cancel out. I'll be left with my moles. Now when I do that, that gives me that the amount of moles for hydrogen is 24.75 moles. Okay, that's step one, convert grams to moles. Step 2 is divide each mole calculated by the smallest amount or number of moles that was found during step 1. So if you look at this, I've got 2 different moles here. I've got 6.24 and I've got 24.75. 6.24 is the smallest amount. So what we do is we take each of these and we divide them by 6.24. And that gives us a 1 here. And for our other one, just to make sure our numbers are all good, we end up at 3.97. Now, 3.97 is essentially the same thing here as 4, because we're looking at whole numbers is what we want. And so we have 1 of the carbons and 4 hydrogens. And on step 3, it says the answers from step 2 are the subscripts for each element in the compound's formula. And so our formula then is C. We don't need to put the 1 below there. And I have H and I have 4 of our hydrogens. And that gives you your final formula right there of CH4. Now let's go on to the next one. Number 2. What is the empirical formula of a compound that contains 70 grams of iron and 30 grams of oxygen? Now if you remember right, we actually had percents there earlier, and whenever you see percents, just cross them out and put grams instead. Then what we need to do is convert from grams to moles. So my iron, I have 70 grams, and my oxygen, I have 30 grams. We need to convert from grams to moles. Iron's weight is 55.85, if I remember right. Yes, 55.85 grams per 1 mole. And oxygen is 16.00 grams per 1 mole. Again, grams will cancel out for both of these. And if I take my 70 divided by 55.85, we get 1.25 moles. 30 divided by the 16 for the oxygen would give us 1.875 moles. Okay, the next thing that we need to do is we need to divide the answers of both of these moles by the smallest amount of moles. And that is 1.25. Now, when we do that, it gives us 1 for our Fe, and it gives us 1.875 divided by 1.25. That gives us 1.5. Ooh. Well, I can't have 1.5 for a subscript, okay? I can't put down just 1.5 or 0.5 on it. It's not going to work, okay? I have to have whole numbers. And if you look back at step 3, it's if your number ends with a 0.5, which we have, multiply every number by 2. So we need to multiply this by 2 and this by 2. And when we do this, we get 2 Fe's and we get 3 oxygens. Now those are both whole numbers. That's what we want in our formula. So our final formula is Fe2O3.